So this is where things get interesting and maybe controversial because you could argue this a lot of different ways. But what has happened to NIL? Why isn't it a viable alternative to photolithography today? Well, there are a number of issues that NIL has run up against.
As for ASML, its stock has been highly volatile this year, with an impressive rally getting mostly reversed in recent months, though that's primarily due to geopolitical risks. Now, most DUV machines sold to China have to go through export controls. Hey everyone, Nick and I are still on the road, so we are still Chip Stock Roadshow. We read some really interesting comments in our recent videos. One was really entertaining in particular and said that we talk very slow.
Kasey's mom watches the show. Sorry, folks, she disagrees. You may not want to get into it with her on YouTube. She's going to defend her daughter.
That's right. But we will definitely take the feedback into consideration. We do want to be as direct and concise as possible, so we do need to work on cutting things down. So thanks for the feedback. We appreciate it. So our topic today is, are ASML's days of lithography dominance coming to an end? We are considering ASML and Canon stock, ticker symbol ASML. And for Canon, if you're in the US, that's CAJPY. It's an OTC stock.
Before continuing, let me remind you to hit the like button and subscribe to the channel if this video is helpful as you do your own investment research and increase your knowledge of business and technology. We really appreciate the support, as subscribing to the channel helps us continue putting out content like this.
Right. And so maybe just a little bit of background first on this topic. As we talk about a lot on the show, the semiconductor manufacturing process is already complex and very expensive to execute, and it's getting increasingly so. So as a result of many decades of efforts to shrink down the features of the most advanced chips to make more powerful and energy-efficient computing systems, semiconductor manufacturing complexity and costliness are going to keep rising for the foreseeable future. As a result, there are a lot of industry specialists that have emerged or emerging. They have very defensible business models due to their deep engineering know-how and just the sheer cost and amount of time it would take for competitors to catch up to them. So one of these specialist companies is, of course, ASML Holding, the Netherlands-based lithography equipment specialist in the large wafer fab equipment space. So ASML is the only company that produces equipment utilizing extreme ultraviolet, or EUV, lithography, specifically photolithography, as we'll discuss here today. EUV is, of course, used to make the most powerful, the most advanced logic, networking, and memory chips. ASML also has a dominant stranglehold on other types of lithography equipment, more mature chip manufacturing processes. That's sometimes referred to as DUV, or deep ultraviolet lithography. However, ASML actually isn't a total monopoly, as some say it is. It has some small competitors. One of these is Japan's Canon, CAJPY. Many of you probably know Canon as the camera company, but it's actually a large conglomerate. They have their hands in a lot of things, including semiconductor manufacturing equipment, wafer fab equipment, and the like. So some Canon announcements in recent weeks. Is ASML's dominance coming to an end? Kasey, maybe you take us through your semiconductor industry flowchart here before we continue.
You all have seen this diagram many, many times, but what we're talking about is this very central part of the semiconductor industry, the wafer fab equipment space. Canon and ASML both fall into this part of the industry, the very vital part of making the equipment that makes the chips. In order to shrink down microscopic features of chips, billions of dollars of investment have been poured into wafer fab equipment. those machines that are used to develop the thin discs made of silicon that you'll often see someone holding in a bunny suit. Once those silicon wafers enter a fab, one of the first of many dozens of steps is lithography. Lithography is a process in which a photoresist chemical, which reacts to certain types of light, is uniformly applied to the surface of the wafer. And then ultraviolet light is shown through a photomask, which allows some of the light through and blocks other parts of the light source to make patterns on the wafer coated with photoresist. After that, the photoresist that was not exposed to light is stripped away, leaving behind lines and channels on the wafer surface that later become circuits in a chip, once the wafer fab is finished and the wafer is cut into chips and packaged into a computing system.
So still looking at a chart here, but let's switch to this one that we also share quite a bit. It was originally made by Tech Insights back in 2021. Applied Materials used it in some presentations earlier this year, but this shows the general steps and types of equipment involved in that wafer fabrication process in general chronological order. So again, you can see lithography there on the leftmost part of the chart. Now, this chart, the width of each step shows the relative amount of money spent on each type of equipment, and then the vertical bars of color shows the individual company dominance of that specific equipment type. So the companies shown on this chart are what we call the Fab Five, by far the largest participants in the wafer fab equipment market. Link here to our video and our chart that we put together outlining this particular niche of the semiconductor industry. But you can see ASML in purple, the dominant force in the lithography part of this market. There's also Applied Materials shown in blue, Lam Research displayed in green, Tokyo Electron TEL shown in yellow, and KLA Core, or KLAC, KLAC in orange.
ASML makes the lithography machines that produce the ultraviolet light source that shines through the photomasks and onto those wafers. As you can see from the chart, ASML accounts for most, but not quite all, of lithography equipment revenue. As a side point, ASML also dabbles a bit in metrology and inspection, as indicated by the big bar dominated by KLA Core close to the far right of the chart. You can see our latest videos and articles on metrology companies, KLA Core, Onto Innovation, Nova, and Camtech.
Okay, Kasey, we've got one more chart here. This one to talk about specifically the lithography market revenue. So if we were to zoom in on just that vertical bar in the last chart, here's the general revenue breakdown of that part of the semiconductor manufacturing industry. These are the primary components of that. There are some others, but as you can see, ASML, this is why they make up that big, giant purple wedge of the bar. In fiscal year 2022, over 21 billion euro, almost 22.4 billion US dollars in sales last year. Canon, they call this segment their industrial segment, Canon Industrial, 329 billion Japanese yen, or 2.2 billion US dollars. Nikon Precision Equipment. So again, Japanese conglomerate Nikon, also a camera maker, but dabbles in this lithography equipment. 203 billion Japanese yen, or 1.36 billion US dollars. Another smaller business, Vico Instruments, $646 million in fiscal year 2022. Vico Instruments based in New York State. So some interesting things going on here, Kasey. There's a lot of other companies that dabble in lithography, but the point here, as you can see, ASML far and away hauls in the most revenue from lithography because they're a specialist, with the exception of a little bit of the metrology equipment Kasey mentioned. So that's a little bit of industry background. Kasey, let's get to the news that Canon announced here just a few days ago in the month of October 2023. It sounds like Canon is about to rain on ASML's parade and maybe scoop up some market share from this photolithography dominance. What's going on?
Yes, decades ago, the industry came to a consensus that photolithography, using that light source, was the best way forward to craft smaller featured chips. ASML's research and development, with ample industry mindshare and financial funding along the way, now dominates with its equipment lineup for photolithography. But as Nick mentioned, photolithography isn't the only possible solution. Nanoimprint lithography, or NIL, was another promising tech that involved uniform coating of photoresist on wafers, but then using a mold with all of the tiny peaks and valleys of the future chip's circuitry pressed onto the surface. The photoresist coating would then squeeze into the channels. Ultraviolet light is applied to solidify the photoresist into a resin, and the mold removed reveals that 3D stamp of the chip behind.
We have a video that Canon put together here that I think helps illustrate what this nano imprint lithography does, or NIL, which is an ironic acronym given that it hasn't really been used all that much up to this point. But take a look here at this Canon video.
Semiconductor devices are essential to modern society. You'd be surprised to learn that the total circuit length in a semiconductor chip, mere centimeters in size, is longer than a full marathon course. That's because a semiconductor chip contains more than 10 billion transistors. Semiconductor chips evolve through efforts of circuit miniaturization to achieve the finest possible circuit patterns. Miniaturization has been realized through advances in exposure technology, which etch circuit patterns with light. But now, Canon is pursuing a completely new method of circuit miniaturization. Nanoimprint lithography stamps extremely fine patterns to form circuits. Despite the simplicity of the process, it can achieve lines as 5 as 15 nanometers or even thinner. This new technology upends the conventional wisdom of semiconductor manufacturing. The first step in nanoimprint lithography is resist dispensing. Applying ink ejection technology developed by Canon for its inkjet printers, the optimum amount of droplets of resin, called resist, is applied to precise locations on silicon wafers in order to match the circuit pattern. Next comes imprinting. A mask or a mold onto which a circuit pattern is etched is pressed like a stamp onto the resist-coated wafer, thus forming a circuit pattern. Modern semiconductor chips are created by combining countless layers of stacked circuit patterns. This requires a precise alignment of circuit patterns. Canon has developed technology to overlay circuit patterns with extreme precision by measuring their position with precision finer than 1 nanometer. Circuit pattern deviation occurs in the lower layer. Based on this shape, the heat of the laser beam is adjusted to correct this deviation. The final process is separation. UV light is applied to the mask, hardening the resist. Then the mask is removed. It is very difficult to remove the mask without damaging the circuit patterns, as nanometer-wide circuits are very fragile. Canon developed technology that optimally controls the shape of the mask and wafer. In this way, Canon succeeded in forming nanometer-level circuits. Canon's nanoimprint lithography technology enables both miniaturization and cost reduction. What's more, This technology is expected to significantly reduce power consumption during manufacturing. Canon is poised to revolutionize semiconductor manufacturing.
Canon sells equipment outside of lithography too, like deposition, etch, and various machine components. However, nanoimprint lithography is the tech that gets the most attention, as Canon has been trying to develop it to offer an alternative to ASML's increasingly complex and expensive machinery. A lot of parties have been involved with this NIL technology, and Canon has been a big contributor. It got more serious about it back in 2014 when it acquired the small Austin, Texas-based R&D outfit called Molecular Imprints. This was purchased for under $100 million and is now known as Canon Nanotechnologies.
So this is where things get interesting and maybe controversial, because you could argue this a lot of different ways. But what has happened to NIL? Why isn't it a viable alternative to photolithography today? Well, there are a number of issues that NIL has run up against. There are challenges involving the proper application of the photoresist chemical onto the wafer itself. There's problems with aligning that mold to the wafer properly as it gets pressed onto the wafer. There's also making sure that the photoresist doesn't leak into areas it shouldn't be when the mold is applied. And then you also have the infiltration of contaminants into that photoresist that can make the ultimate chip comes out of that wafer totally useless. Also, once the mold is applied and ultraviolet light applied to turn that photoresist into a resin, once the mold is removed, there's issues with warping that can take place as the mold is pulled away from the wafer. So a lot of issues that Canon and some other companies have been trying to overcome with NIL that has indeed made it a zero, a nil for the most part when it comes to manufacturing chips. But photolithography, interestingly, also had a lot of different obstacles with physics and with chemistry, but it just simply got all the funding, all the attention, all the mind share of the industry, and over the years overcame these obstacles. So you could argue NIL won't be a zero for forever because companies like Canon have been funneling a lot of research and development and money into this technology.
But Canon and other NIL developers such as Nano, Nex, EV Group, and SUSE Microtech still think NIL is ready, especially as it can be far cheaper and perhaps even quicker, given that patterns can be stamped onto a wafer in a single step to operate versus photolithography. There are applications for this nano imprint lithography in non-chip manufacturing, such as with LED or OLED displays. DRAM and NAND memory chip manufacturing is also another possibility, and one Canon has been really excited about.
Right. Yeah. So it's in this extremely cost-sensitive memory chip manufacturing market that Canon hopes to finally begin making waves. So after delivering multiple NIL machines for test and development over the years, Canon recently announced the availability of what it calls the FPA 1200 NZ2C model. A little clip from the announcement from the press release that Canon made. And to sum this up, Kasey, what this announcement is saying, 5 nanometer, and with some tweaks and further R&D, they can maybe get this down to 2 nanometer chip production. Canon thinks this latest machine could actually compete with ASML's top of the line EUV machines, which are currently working hard at TSMC, Intel, and Samsung fabs at the 5 nanometer, 3 nanometer, and 2 nanometer and equivalent manufacturing processes.
Over the years, nano imprint lithography machines from Canon Nanotechnology have been delivered to Toshiba, which partners with memory chip maker Western Digital. Toshiba has also partnered with memory giant SK Hynix, part of the South Korean conglomerate SK Group, to also work on NIL in DRAM and NAND memory chips.
Okay, so Kasey, I think let's maybe ask this question before we continue. Will NIL developments that Canon has recently announced make Canon stock a good investment?
That's a good question. But only 8% of total sales last year were attributed to wafer fab equipment for Canon. So at this point, we don't really know if this new Nano imprint lithography machine is going to move the needle for Canon sales at this point.
The first takeaway here, that's a good slide that you show here, Kasey. This is a very, very small segment for Canon. And in the meantime, the rest of the business has been basically no growth or overall declining revenue, declining sales for Canon over the last decade. They've really struggled to boost profit margins, as you can see from this financial chart. So I think that's the first takeaway here. We're not talking about all of this technology in the light of Canon being a high quality, long-term stock for investors to own. So I think that's our first takeaway here. However, there is a second question, and this is obviously where I think most investors are tuning in because there's some concern. Is this a risk for ASML? If nano imprint lithography takes off, that doesn't make Canon a great stock to own, but does it make ASML maybe a not so great investment anymore?
In past videos, we have talked about this. We've talked about alternatives to photolithography as a risk to ASML's long-term dominance. The semiconductor manufacturing industry has lined up for DUV and EUV machines to chart a path on their future chip development roadmaps. That kind of multi-billion-dollar and multi-year development pipeline isn't going to quickly disappear.
So let's maybe talk about that a little bit in some more depth, because everyone talks about EUV, extreme ultraviolet lithography equipment. But interestingly, it's still, as we talked about in our last two videos on ASML, it's DUV, deep ultraviolet, the older, more mature manufacturing processes that are actually making up the bulk of ASML revenue this year. So these DUV machines, we can break into a few different categories. So first, there's what's known as dry lithography. That's just the ultraviolet laser that gets projected through the air onto the wafer. Then there's also what's known as wet or immersion lithography. That's where the UV laser is shown through a droplet of water to make that laser sharper, and make the resolution, the wavelength smaller to get even smaller features on the chip. So there's dry and wet lithography. Then there's also two different types of UV light sources. There's ARF or argon fluoride lasers. And then there's also KRF or krypton fluoride. So if you remember your chemistry class back in the day, you recognize argon, krypton, and fluoride as gases. So these act as the light source for those lasers. A couple of different technologies at work here in DUV. These DUV machines can cost tens of millions of euros each. And this is where most of ASML's revenue is coming from. They have a dominant share even of this DUV, deep ultraviolet market, because of the breadth and depth of their know-how in physics and chemistry. And most companies that want to fabricate wafers continue to rely on ASML because this is tried and true technology, and it is not easy to compete against ASML because of their technological lead. Now, as far as EUV goes, this is where we think things could get a bit more interesting. So as ASML has been reporting the last couple of years with EUV machines, they're starting to sell some of these, and they're fast approaching 200 million euro a pop. Some of them, it seems like it's maybe already crossed the 200 million US dollars threshold for each machine. And the next generation of these, the high NA EUV, which Intel has said it will be the first to use in production by 2025. It sounds like Intel is already testing these high NA EUV machines out in their fabs. These things are going to cost over $300 million, up to possibly 400 million euros each. This is why we introduced this video talking about how continuing to shrink down the features of chips gets more complex, it gets more expensive. And what could happen as this occurs, Kasey? Why does this become a possible risk for ASML?
Chip manufacturers are going to be more open to conversations about alternatives to chip manufacturing. For example, earlier this year, Applied Materials announced a new type of machine that performs a step called pattern shaping, and that was the Centura Sculpta machine. And that's complementary to ASML's lithography machines. Pattern shaping could reduce the number of lithography exposure steps, and that's called multi-patterning, with some wafers getting exposed to UV lasers dozens of times. This could lower the total cost of production with lower energy usage and quicker production times. And we talked about that a little bit in our Huawei video regarding making the 7-nanometer chip that went into the Huawei Mate 60 Pro.
Yeah. And Kasey, you mentioned that word complementary. And so the Centura Sculpta machine from Applied Materials, we think overall it's complementary to ASML DUV and EUV machines, because if these things are expensive to operate, DUV and EUV machines are complex and expensive, not just to buy, but also to operate on an ongoing basis. If those lithography steps get more simple and maybe a little less costly, maybe a company is willing to adopt some of these more advanced manufacturing steps and buy ASML equipment. But it nevertheless illustrates the fact that as this CapEx intensity increases, companies might be looking for other complementary equipment to get the job done. So this is one example of how this could play out over time. We actually do have another example here, though, that's worth noting, specifically on EUV equipment. EUV machine adoption hasn't been a cakewalk at all this year, right, Kasey?
Yeah, Taiwan Semiconductor manufacturing has been having issues scaling its latest 3-nanometer process. This is perhaps due to EUV challenges, and ASML itself has said that its customers have pushed out delivery of new EUV machines. DUV machine sales, particularly to China, have been what's offset the effect in 2023, but further EUV adoption delays could certainly happen.
Yeah, and this remains to be seen, I think, but it sounds like, ASML says this push off of EUV is just simply because of the economic situation in 2023, but it could be more than that, though, too. Some of these companies have said that high NA EUV, for example, was going to start hitting production in 2024. Now it sounds like it's been pushed out to 2025. Again, folks, when we're talking about chip features this small, 2, 3, 4, 5 nanometers in dimension, this is microscopic. We're talking about features that are in some cases just tens of atoms thick. Weird things start to happen at the atomic level. There are lots of complications with this. It's not easy to pull off. So this could throttle ASML's growth going forward.
Perhaps Canon's NIL machines will finally start to pay off as these complexities mount. As for ASML, its stock has been highly volatile this year, with an impressive rally getting mostly reversed in recent months, though that's primarily due to geopolitical risks. That geopolitical risk, of course, is the export of machines to China. EUV and now most DUV machines sold to China have to go through export controls. So let's talk about valuation before we close this video out, Nick. What is the valuation for ASML?
Okay, so as of this recording, the morning of October 17th, 2023, ASML stock has popped up higher just a little bit, about $608 a share. That values it at a pretty high premium in spite of the recent pullback. 31 times trailing 12-month earnings per share, about 40 times trailing 12-month free cash flow. What does that mean? The market overall still thinks very much that ASML is a dead ringer for long-term growth.
Yes, semiconductors are a massive and still high growth market. It's expected around a 7% CAGR through 2030, and there will be plenty of need for more ASML. We have a long position in the stock, which we initiated last autumn, but at that time, the stock carried a depressed valuation.
So fast forward to today, mid-October, a year after that purchase that we made when the stock was miraculously in the high $300 per share range. The current premium on the stock, we think, warrants more caution for investors that are wanting to get into ASML now. So risks should be kept in mind. And one of them, we think, is possible adoption of alternatives to photolithography equipment. Maybe it's Canon's nanoimprint lithography. Maybe it's something else. Maybe it's just simply adoption of newer and better and more expensive photolithography machines getting throttled a bit going forward. At any rate, ASML isn't cheap. We think investors should tread carefully, perhaps scale into a position over time because of that high valuation. Think about doing some sort of dollar cost averaging plan at this point if you like ASML's prospects over the course of the next decade like we do.
Thanks everyone for watching this episode today on ASML and Canon stock analysis. We hope that you enjoyed it, and make sure you hit the subscribe button for more videos coming up this week.
Also, just a reminder, this was a pretty dense topic. If you missed the links in the video, links below to some of the background information that might help you understand some of these topics that we discussed on DUV and EUV technology. And as for later this week, it's almost earnings season again for the semiconductor industry. So as companies report earnings, we will be making some updates on that financial information when it comes out. Also, Kasey, we wanted to address a topic about infinitely scalable businesses versus businesses that are perceived to not be infinitely scalable. One of them being the semiconductor industry. We're going to have some thoughts recorded on that. Some rants, maybe even.
Oh boy. All right, see you next time at Chipstock Investor.